this object starts to fall from point A to point B, the height is h. Then from the starting point, the object is stationary, and when it reaches point B, it gains the velocity vb. Va equals 0, and the height drops from this point to the ground. And we say that the potential energy from point A to point B decreases by mgh, as potential energy is a relative quantity. So we say that at ground, the potential energy is 0. Then at point A, the potential energy is mgh. When as gravitational force is a conservative force, so when the object falls from point A to point B, the potential energy is converted to kinetic energy. So let's calculate how much the work is to move to pull the how much the work the gravitational force has done to pull the object from point A to point B, and how much the kinetic energy is when the object reaches point B. Okay, and W it's the work done by the gravitational force is mgh. Mg is the gravitational force, h is the height. This is also the potential energy of the object at point A, because it has the height h, and delta h is the distance the object falls. Delta h equals delta t times v. V is the velocity of the object. It is changing, and it's changing with time, and dW is the work done by gravitational force, and that is mg dt times v, and g is dv over dt, the changing of speed. So the integral of the work done by gravitational force from point A to point B is this mg timing dt timing v, integral starting from A to B, and the total work is mg gh, and dt cancelled, so this is mdv v, and that is 1/2 mv squared starting from A to B, and that is 1/2 mvb squared minus 1/2 mva squared. And the difference of the kinetic energy is the work done by the gravitational force, as the Va is the starting velocity, that is 0. So and Vp is the ending velocity at point B. So this is a 0. And the work done by gravitational force through the work done by gravitational force, the potential energy of the object at point A is converted to the kinetic energy at point B. The mechanical energy as the gravitational force is conservative force, and the only force done to the object is the gravitational force. So the mechanical energy is the same for the object at point A and point B. And mechanical energy is the total of potential energy and kinetic energy. At point A, kinetic energy is 0 and potential energy is mgh. At point B, the potential energy is 0 and kinetic energy is mgh. mgh, this is a dw mgh. The integral of dw is actually mgh, but I have converted to the expression of the function of a v. So we get the relation, the connection between the potential energy and the work done by the gravitational force with the kinetic energy.